Plane capacitor. In this example, we're going to simulate the plane capacitor with the non-ideal dielectric media between the plates. Non-ideal means that there are losses in the dielectric at the alternating field. And the alternating voltage source is indeed connected to the capacitor terminals. Our task is to find the losses. We know the dielectric permittivity and the loss tangent. Using these values, we can calculate the effective conductivity of the dielectric. You can see the equation here. I'm going to use the effective conductivity to calculate the active component of the electric current and to calculate the losses. Okay, let's start QuickField now. In QuickField, I create new problem, capacitor. Next. Problem type is AC conduction. Every simulated device is a three-dimensional object. I'm going to simulate only a single cross-section of the capacitor, so the model class is plane parallel. Length units are millimeters, and the capacitor axle length is 10 millimeters. Frequency is 1 megahertz. Finish. On the left you can see the problem pane, and on the right is the geometry model editor window. You can draw the geometry model here, or you can import the geometry model from the AutoCAD.exe file. The model is simple, so I'm going to draw it here from scratch. First, I will insert a rectangle with dimensions 0.1 mm by 10 mm. Insert. Close, zoom to fit. Now let's assign labels. Through labels we can distinguish objects and provide material properties. I will zoom in so you can see that this is indeed a rectangle. Switch the zooming mode off, switch to select objects mode, and click the object to select. This is the dielectric. This is left plate, and this is right plate. Okay, so far these are just text labels. Now let's provide physical properties for these labels. Left plane will be grounded, 0 electric potential, and right plate is connected to the alternating voltage source with this frequency, and the voltage magnitude is 5 volts. Okay. For the dielectric, I specify electric permittivity, which is 10, and electrical conductivity. I will provide a parent value of electrical conductivity that takes into account both the dielectric conductivity at DC current and the losses at alternating field. So I type in here 5.56 times 10 to the power of -6 Siemens per meter. Okay. Before I run the analysis, I should build the finite element mesh in geometry model. Just press this button and the mesh will be generated. Now save all problem files and solve the problem. Now let's take a look at the results. Again, let's zoom in. You can see the field lines and the color map of electric field strength. Let's adjust the field picture. I will switch off the color map and switch on the vectors of the current density active component. Okay. Now remember, we have the alternating electric field, and this picture is displayed for some specific moment of time. We can change the moment of time, and the field picture should change as well. In QuickField, in AC problems, it is called the phase. Now the phase is 0. I'm going to change it to 5, 10. Oh, let me switch on the animation. Indeed, we have an oscillating electric field. Switch the animation off. I'm going to use the contour tool to measure the current. I'll click one plate or another. Let's zoom to fit. You see the contour was created along this plate. And now I can follow to the integrals and calculate the active current. Here it is. This is the active current through the 100 mm square area of the capacitor plate. Okay, my task is to calculate losses. Again, I will use the contour tool, but this time, contour clear, this time I'm going to select the dielectric media. Contour tool, click inside. You see the dielectric media is selected, and I can calculate volume integrals. Active power produced in a volume. And the block volume is 10 millimeters cubed. So this is the total power loss in the capacitor at a frequency of 1 MHz. If you search for the plain capacitor on our website, you will find the example page. Here you can read about problem setup, browse the solution section, take a look at the resulting pictures, and download the simulation files. Simulation files may be opened and the results may be viewed using any QuickField edition, including QuickField Student Edition that you can download from our website for free.